Greeting of the day, dear students. Myself Harish Kumar, and today we are going to learn the 5th chapter of class 10th called Arithmetic Progression. Dear students, in this video lecture we will deal with some concept such as what is sequence, what is arithmetic progression, what is the meaning and definition of arithmetic progression, what are the types of arithmetic progression. We will see the nth formula for the arithmetic progression, which is also known to be the general formula for the arithmetic progression. We will see some of the first nth term formula for the arithmetic progression, and we will also see the relationship between the nth term formula and the sum of the first nth term formula of an arithmetic progression. At the end of the video, we will see some board questions for practice. So without wasting time, let's just start with our topic. Sequence. Dear students, a sequence is a list of number which follows some rules or the pattern. They follow some rules or the pattern, and each number is called term, and each number is called term. For example, dear students, we have sequence of a natural number. We all know that all the counting numbers are known as a natural number, which starts from 1, 2, 3, 4, dash dash dash. Okay, so here you can see that they follow certain pattern, like each successive term is differ by preceding term by plus ka 1. This is in this sequence of a natural number. If this 2 is called successive term of 1, whereas 1 is the preceding term of a number 2. Likewise, 4 is a successive term of the number 3, and 3 is a preceding term of the number 4. Let us take more example. Suppose we have sequence of a even number. Okay, so we all know that even numbers are the number which are completely divisible by 2. For example, 2, 4, 6, 8, 10, 12, 14, dash dash dash. These are our sequence of an even number. You can see that they have followed some special rule or the pattern, we can say, like each preceding term differ to the successive term by some pattern. Here it is plus 2, here also plus 2. Okay, each term is differ by their successive term by plus ka 2. Let us take more example. Suppose if I write suppose I am writing the sequence of square. Okay, like we have 1 ka square is 1, 2 ka square is 4, 3 ka square is 9, 4 ka square is 16 and 25, like this, so on. Okay, here you can see that this is called a sequence, which is like a sequence of a natural number. So it is 1 is the square of 1, 4 is the square of 2 ka square, 9 is the square of 3 ka, okay, and 16 is the square of 4. Likewise, they have followed certain pattern. So this is called the sequence of a square. Suppose I take example, say sequence of a cube, like 1, then 2 ka square is 8, 27, then 64, 125, like this. So they also follow certain pattern, dear students, like they are the cube of a natural number. So these are called the sequence. They call the sequence because this is the list of term and each term has follows certain rules or the pattern, so they call the sequence. Now dear students, question arises that can we say that all the sequence are arithmetic progression? If not, then what is arithmetic progression? Let us see. Now dear students, we are going to learn the meaning and definition of arithmetic progression. In general, dear students, suppose for a given sequence of AP, for each term, for each successive term, if the number differ from its preceding term with some constant, then that sequence is known to be the arithmetic progression. Let me write the definition of a arithmetic progression. So, a sequence A1, A2, A3, dash dash dash, AN is said to be arithmetic progression if each successive term differ from its preceding term by a fixed number and that fixed number is called common difference. Okay, so dear student, let's just take example. Suppose I have written one sequence which is -3 -1 -3 -1 1 3 5 7. This is a sequence. As you can see that each successive term, like for this, the preceding term is this. So -1 minus -3 is what? It's -1 plus ka 3, which is plus ka 2. And if you take any random term, suppose this is our first term, this is second term, this is third term, this is fourth term, this is fifth term, this is sixth term. Okay, so if I take the fourth term and third term, here also the difference is 3 minus 1, which is 2. If I take this sixth term and fifth term, here also the difference is 7 minus 5, which is again 2. So you can see in this sequence, which is -3 -1 1 3 5 7, here each successive term is differ to its preceding term with some common number, which is here it is 2. So this 2 is known to be the common difference of this sequence. Okay, let us take another example. Suppose I write 2 7 12 and 17 dash dash dash. Here this is the sequence. Okay, since you can see that this 7 and 2 has a difference of minus plus ka 5, 12 and 7 has difference of 5, 17 and 12 has a difference of 5. So this sequence, so we can say that for this given sequence we have the common difference 5. So this sequence are said to be the arithmetic progression. Dear students, keep in your mind that not all the sequence are arithmetic progression. Suppose, dear students, I write the sequence of square. Suppose 1 4 9 16 and 25. Okay, dash dash dash. we are saying that this is a sequence, okay, because this is the square of 1, this is square of 2, this is square of 3, this is square of 4, this is square of 5. So they follow certain pattern, so they are the sequence by the definition of sequence. But is it true that this is the arithmetic progression? No. Why? Because, dear students, as you can see that the definition of arithmetic progression says that if each successive term differ from its preceding term by fixed number. Here you can see that the difference between this second term and first term is 3, but the difference between third term and second term is something like a 5, and the difference between fourth term and third term is difference of 7. So they are not having some common term, okay, which is known to be the common difference. Like here we have got 2 as a common difference. In the second example we have got 5 as a common difference. But in question number 3, this sequence of a square does not follow the rule of a arithmetic progression. So although it is a sequence, okay, but not a arithmetic progression. This is a sequence but not a arithmetic progression. Let us take one more example. Suppose, dear students, I take the sequence of cube number. So we are having cube are 1, okay, we are having 8, we are having 27, 64 and 125 dash dash dash. This is the sequence of cube. So here also you can see that this is sequence because each term have some pattern or the rule, okay. But is it possible that this example 4 is a arithmetic progression? No, this is not possible, because here the difference between 8 and 1 is 7, but the difference between 27 and 8 is here 19, and they have some, like, they are not having some regular common difference, so they are not said to be the arithmetic progression, okay. So I hope you have all understood that not all the sequence are said to be the arithmetic progression, okay. A list of number may follow certain rules or the pattern, but it is not always said to be the arithmetic progression. For the arithmetic progression, the list of number, like for each successive term, should differ to the preceding term with some constant or the fixed number, okay. Each consecutive term in arithmetic progression are differ by some constant term, then only they are said to be the arithmetic progression. Otherwise they are just sequence, not a arithmetic progression. Here we have seen first 2 example is sequence as well as arithmetic progression, because they by definition they follow both condition. But example number 3 and example number 4, although they are sequence, but they are not the arithmetic progression, okay. I hope you all are getting the things. Now let us see some terms which are involved in arithmetic progression, like what is first term, what is nth term, what is common difference, and what is the general formula for the nth term of an AP. Suppose, dear students, let A1, A2, A3 dash 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 AN be a sequence of arithmetic progression, okay, which are differ to its successive term to preceding term by common difference, say small d. Okay, so as we know that for any sequence of arithmetic progression, the successive term differ from its preceding term by some fixed number which is known as common difference. Suppose dear students, this is suppose dear students, a of n is some term, so the common difference will be a n plus 1 minus a n. Okay, so for here a1 is the first term which will be just a. Okay, talking about the second term, this is second term, and this will be a plus d. Why? Because here for a1, which is the preceding term for the a2, so here common difference is a2 minus a1. Since a2 is a plus d minus a1 is a, this will give us a plus d minus a plus a will get cancelled out, only the common difference will d will remain. So if the first term is a, then the second term will be a plus d. Likewise the third term will be a plus d, which is a plus 2d. Yes or no? Yes. Similarly dear students, a4 will be the fourth term which can be written as a plus 3d. Okay, here dear students, you can observe that for a second term we are getting a plus d, for the third term we are getting a plus 2d, for the fourth term we are getting a plus 3d. Likewise, if we repeat the things continuously, we will get for the nth term we will get a plus n minus 1 d. This is the general formula for the nth term. Okay, thus the general formula for nth term of an AP is given by an, which is equals to a plus n minus 1 d, where a is the first term, d is common difference. Okay, now dear students, to understand the nth term of an AP better, let me take one example. Suppose dear students, we are given a sequence of AP. We are given for a sequence of AP 55, 60, 65, 70 dash 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 100. Find the value of n. Dear students, this is our sequence of AP. We aim to find the value of n. So by looking the sequence of AP, it is clear that the first term is 55, second term is 60, third term is 65, and fourth term is 70 dash dash dash. The nth term is 100. Okay, and we know that the nth term of an AP is given by this formula. So from here we can calculate the value of d, which is common difference. This may be a2 minus a1 or a3 minus a2 dash dash dash, or you can say an plus 1 minus an, which is the value of d. Okay, so here the value of d is 60 minus 55, or you can say that 65 minus 60. So the value of D is just 5. Okay. So we have got the value of D is equals to just 5. Now dear students, we will substitute the value of nth term, first term and the common difference in this formula. So by substituting the value, we get here an is 100, the first term is 55, n minus 1, and the common difference, that is the value of small d is 5 here. Okay, so this will give 100 minus 55 is equals to n minus 1 into 5. This will give 100 minus 55 is 45, and this will give n minus 1 into 5. Here we can transpose this 5 to divide 45. So we will get 45 divided by 5, which is just 9, is equals to n minus 1. Thus the value of n will be 9 plus 1, which is just 10. So the value of n is 10. Okay, so in this way, dear students, for this nth term of an AP, we are having an, a, n and d. We are having 4 different terms. So the examiner may sometime ask you, by providing any three term, they will ask you to find the 4th term. Suppose, dear students, for this particular given sequence of AP, the examiner asks you to find the 7th term. Okay, so in order to find the 7th term, we will again use this nth term of an AP formula. So in order to find the 7th term, what we will do? So the A7th will be first term plus 7 minus 1 into common difference D. Okay, here for this given sequence of AP, we can find that the value of the first term is 55 and the value of common difference is 5. So putting the value of first term and the common difference over here, so you will get the value of the 7th term will be A is 55, 7 minus 1 is 6, and the value of D is 5. This will give 55 plus 6 into 5 is 30. So 85 is the 7th term of the given sequence of an AP. Okay. Now students, I have written one questions for you. It says that the sum of the 5th and the 9th term of an AP is 30. If its 25th term is 3 times its 8th term, find the AP. Dear students, we have to find the sequence of AP if the sum of 5th term and 9th term is 30 and given that the 25th term is 3 times the 8th term. So everyone pause the video and try to solve the question by your own. Here it is given that A5 plus A9 is equals to 30. That means the sum of the 5th and the 9th term is 30, and it is also given that the 25th term is 3 times of the 8th term, that is A8. Okay, so now let's just expand it in the formula. So we will get the 5th term can be written as A plus 5 minus 1 D plus 9th term can be written as A plus 9 minus 1 D is equals to 30. Okay, and this will give us A plus 4D plus A plus 8D is equals to 30. This will give us A will added up to 2A, 4D plus 8D is 12D, which is equals to 30. Here we can take 2 common, so we will get 2A plus 6D is equals to 30. This will give us a plus 6d is equals to 30 divided by 2, which is 15. Okay, so we are having a plus 6d is equals to 15. Okay, dear students, you can observe that this a plus 6d is nothing but the 7th term only, na? So for the 7th term of the given AP is 15, it is saying. Okay, on the other hand, if I see this condition, I will get 25th term can be written as a plus 25th minus 1 into d is equals to 3 times 8th term can be written as a plus 8 minus 1 into d. Okay, this will give us a plus 24d is equals to 3 times a plus 7d. Okay, now open this RHS. We will get a plus 24d is equals to 3a plus 3 into 7 is 21d. Okay, this is d, and that will give number 21. Here, while transposing, we should keep in our mind that the one which is having lesser value is being transported to other side. Here you can say that 24d and 21d, out of which one is greater? 24d is greater. So I will transpose this to over here, and since 3a, out of 3a and a, 3a is having greater mass, so I will transpose this lower mass to that side. So it will give me 24d minus 21d is equals to 3a minus a. This will give 24d minus 21d is 3d, and 3a minus a is 2a. This gives the value of d is equals to 2 divided by 3 into a. Okay, so now what we will do, let us take this as a equation number 1, and this as a equation number 2. Okay, now dear students, what we will do, we will substitute the value of equation 2 over equation number 1. So what we will get here over here is that a plus 6 into the value of d is 2, 3 into a is equals to 15. Here 6 will get 2 times from the 3, and 2 into 2 is 4. So we are having a plus 4a is equals to 15. This will give the value of a plus 4a is 5a, which is equals to 15. So value of a is 15 upon 5, which is just 3. So we are having the first term a is equals to 3, and we know that the sequence of AP is given by a plus d, a plus 2d dash dash dash. Okay, so the value of a is 3. So in order to find the value of d, we can put this value of a, let us say it is equation number 3. So if we put the equation 3 in equation number 2, we get the value of d is equals to 2 into 3, value of a is 3, so 3 will get cancelled out, the value of d is 2. Okay, so we have the value of first term is equals to 3, and the value of d, which is a common difference, is 2. So putting the value of a and d in the sequence of AP, we will get the value of a is 3 and a plus d, that is 3 plus 2 is our next term, and a, that is 3 plus 2 into 2, that will be our third term. So the sequence of AP that remain with us is 3 plus 2 is 5, 3 plus 2 into 2, that is 4, 3 plus 4 is 7, and next number will be 9, 11, 13. This is our sequence of AP. Okay, so in this way, dear student, we can solve the questions based on the nth term of an sequence of an AP. Okay, I hope you have understood the things properly. Dear students, solving the word statement problem are always been crucial for the examination. So keeping this in our mind, I have come up with one more example. The question is that find the number of a natural number between 101 to 999 which are divisible by 2 and 5 both. Dear students, in this question we have to find the number which lies between 101 to 999 which are completely divisible by the number 2 and 5 both. I request you all to pause the video and try to solve this question by your own. Otherwise, I am solving this question. Dear students, we all know that what is natural number. So all the counting number are known as a natural number. Okay. And we also know the condition to be divisible by 2. What are the conditions to be divisible by 2? That for any number to be divisible by 2, the number should be even number. That means it should always end with the digits such as 0, 2, 4, 6, 8. Okay, then only a number is said to be divisible by 2. Similarly, for a number to be divisible by 5, the unit digit of that particular number should either be 0 or 5. So we have to check for the number which lies between 101 to 999 which are divisible by both 2 and 5. So let's just try to write. So if I write from number 101 to 999, I can see the first number which is divisible by 5 is 105. Okay, but 105 is not divisible by 2, so we will not consider it. Why it is not divisible by 2, sir? Because here it is odd number, na? The unit place of 105 is odd number, so it will not divisible by 2. So the next number which is divisible by 5 is 110, that is 110, and 110 can be divisible by 2. Yes, it can be divisible by 2. Okay, so the next number which can be divisible by 5 is 115, but 115 is not divisible by 2, so it will not be considered. 120, okay, 120 is divisible by 5 and both 2 also. Okay, now next one is 125 is also not divisible by 2, so next one will be most probably 130, and this will go repeatedly. And near to 999 we can choose the value 995, but here 995 is not divisible by 2, although it is divisible by 5, so we will not consider this also. Now taking the number previous to 995, we will have 990. Okay, 990. So 990 is divisible by 5 and it is also divisible by 2. Okay, so the number lies between 101 to 999 are 110, 120, 130 -990. Okay, this is the required sequence of AP that we should have. Here clearly we can say that the value of A, that is the first term, is 110. The value of A2, that is second term, is 120, and the value of third term is 130, and nth term is 990. Okay. Now dear students, we aim to find the common difference. Obviously the common difference, we can see that what is common difference? It is the difference of each successive term with the preceding term. Here 120 minus 110 or 130 minus 120 is equals to 10 only. So the common difference is 10. Okay. Now we will put our given things on the nth term formula. We all know that nth term formula for an AP is given by an is equals to a plus n minus 1 into d. Okay, so value of an is 990. What is value of a? it's 110, and we have to find, okay, and we have to find n minus 1. I am just writing it as it is. The value of common difference is 10 here, so let's just write. What I will get? 990 minus 110 is equals to n minus 1 into 100. This will give 880 is equals to n minus 1 into 10. 0 will get cancelled out. This will give n 88 is equals to n minus 1. So the value of n is 88 plus 1, which is 89. So that means, dear students, there are 89 natural number which lies between 101 to 9999, which are completely divisible by 2 as well as 5. I hope you have understood this question. Dear students, I have one important concept about arithmetic progression to share with you. Like suppose we are given 3 consecutive terms of an arithmetic progression. Then, dear students, always remember that the sum of, for a given 3 consecutive terms of an arithmetic progression, the sum of first and third divided by 2 is always equal to the middle term. Let us write what I am saying. Let a plus d, a plus 2d be the 3 consecutive terms of an arithmetic progression. Terms of an arithmetic progression. Then the sum of first and third divided by 2, that is a plus 2d divided by 2 is always equals to the middle term, that is a plus d. Okay, so here you can verify this concept also by solving it. Like a plus a is 2a, 2d divided by 2, which will be equals to a plus d. Here divided by 2 is equals to a plus d. 2 will get cancelled out. This will be a plus d, which is equals to a plus d. Here LHS is equals to the RHS. Dear students, based on the same concept, I have one question for you. Dear students, one question might be visible to you in your screen. Let me read it for you. For what value of k will the consecutive term 2k plus 1, 3k plus 3 and 5k minus 1 forms an AP? Okay. So everyone pause the video and try to solve the question by your own. Okay, dear students, here we are given 3 consecutive terms, 2k plus 1, 3k plus 3 and 5k minus 1. They are in AP and we are aim to find the value of k. So by using the concept that for any 3 consecutive term, the sum of first and third term divided by 2 is always equals to the middle term, that we will use to solve this question. So if 2k plus 1, 3k plus 3 and 5k minus 1 are in a AP, so clearly the sum of first term and the third term divided by 2 should be equals to the middle term. So 2k plus 1 plus 5k minus 1 divided by 2, that should be equals to 3k plus 3. Here on solving this, we can see that 2k plus 5k is 7k. 1 and minus 1 will get cancelled out. Divide by 2, which is equals to 3k plus 3. Here 7k is equals to 2 times of 3k plus 3. And here by opening this bracket we will get 2 into 3, 6k plus 6. Here transposing this on the LHS we will get 7k minus 6k, which is equals to 6. So the value of k is just 6. So for the value of k, which is equals to 6, these given consecutive terms are the terms of the arithmetic progression. Okay, let us solve one more question. Dear students, one question might be visible to you in your screen. Let me read it for you. The first 3 terms of an arithmetic progression respectively are 3y minus 1, 3y plus 5 and 5y plus 1. Then y equals to option number A minus 3, B 4, C 5, D 2. Everyone pause the video and try to solve this particular question by using the same concept that I have taught you just now. Pause the video and try it by your own. Okay, dear students, we are given 3 consecutive terms, 3y minus 1, 3y plus 5 and 5y plus 1. Okay, so we all know that whenever 3 consecutive terms of an arithmetic progression are there, so the sum of first and third term divided by 2 is the equals to the middle term, or we can say that the average of first term and third term is equals to the middle term. So here for this particular question, this will be 3y minus 1 plus 5y plus 1 divided by 2. That should be equals to 3y plus 5. Okay, so here 3y 5y is 8y, minus 1 plus 1 will get cancelled out, divide by 2, which is equals to 3y plus 5. Here this will be 4 times, so 4y is equals to 3y plus 5. Here transposing this over here, you will get 4y minus 3y is equals to 5. Thus the value of y is equals to the 5. Okay, so the value of y is equals to 5. Thus here we can say the option number C is correct for this particular question. Okay, option number C is correct for this particular question. Now dear students, let us see more question based on it. Dear student, one question is there on your whiteboard. The next term of an AP root 7, root 28, root 63 is option A root 70, B root 80, C root 97, D root 112. Everyone pause the video and try to solve by your own. Here dear students, we are given first term is root 7 and the second term is root 28 and the third term is root 63. We aim to find the next term. Okay, so can I write the number inside the root in terms of 7? Like I can write root 28 as a root 7 into 4 because 7 4s are 28. Likewise I can write root 63 as a root 7 into 9 because 7 nines are 63. Okay, so this will give root 7 here. Root 7 4 can be written as 2 ka square, and here also root 7 into 9 can be written as 3 ka square. Okay, so this implies that root 7, this 2 square will come out of the root, so it will be 2 root 7, and here 3 square, so 3 will come out of the under root, so it will be 3 root 7. Okay, here you can observe that the common difference is 2 root 7 minus root 7, which is just root 7. Okay, if I add common difference, d is equal to root 7 over the next, I will get 3 root 7 plus root 7. Okay, this will be 4 root 7, and here I can write it as 7 into 4 ka square. Okay, and that I can write it as 7 into 16. Okay, and 7 into 16 is how much? It's a 112. Okay, because 16 sevens are 112. So the answer is root 112, which is option number D. Option number D is correct. Hope you have understood this question. Now dear students, we are going to derive the formula for the sum of the first nth term of an AP. So let's just go for it. Suppose dear students, we are having let a plus d, a plus 2d and dash 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 a plus n minus 1 d be the sequence of an AP. Okay, we have considered the sequence of AP like this. Okay, now we aim to add the first n term. So what we will do, we will write let S be the sum of first nth n term. Okay, so I will write S is equals to a plus d plus a plus 2d plus dash 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 a n minus 1 d. Okay, now can I rewrite this in a reverse order? So I will get S will be equals to a n minus 1 d plus I will get a n minus 2 d. A n minus 2 d will be the term which is the preceding term for this nth term. Okay, and this is our n term, so n minus 1 term will be a plus n minus 2 term. Okay, so a plus n minus 2 bracket d is the preceding term for this. This will be dash 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 a plus 2d plus a plus d plus a only. Okay, suppose this is equation number 1 and this is equation number 2. Now adding 1 and 2, what I will get? S plus S will be equals to, here we will add this to this term to this term. Okay, and likewise we will repeat the things. So we will have S plus S is equals to 2S, which is equals to now adding equation 1 and equation number 2, we will get 2s is equals to a plus a n minus 1d. This will give 2a n minus 1 d. Okay, and next term is a plus d, a plus n minus 2 d. A plus a, that will be 2a, and d taking common from here will get n minus 2 plus 1 whole d. Okay, and from this will repeat, so I am just putting dash dash dash, and the last term will be a plus n minus 1 d, and this, so a is 2a n minus 1 bracket d. Okay, this can be rewritten as 2a n minus 1 d. This can be rewritten as 2a n minus 2 plus 1 is minus 1, so n minus 1 d plus dash 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 2a n minus 1 d. Okay, here dear students, you can observe that this 2a n minus d, 2a n minus d, 2a n minus d are repeating itself for the n times. So I can simply multiply with n, and I can write n into 2a plus n minus 1 d, and here this will give 2s, the value of 2s is this, the value of s will be n divided by 2, 2a plus n minus 1 d, and this is called the sum of the first n term, where a is the first term, d is the common difference. Okay dear students, this is called the sum of first n term. Now let us solve some question based on it. Suppose dear students, the examiner asks you to find the sum of the first 100 sum of a natural number. Okay, suppose the examiner asks you to find the sum of first 100 terms of a natural number. So how to solve this question? We all know that natural number starts from 1, 2, 3 dash dash dash. It will go till finite. Okay. Here the first term is 1, the second term is 2, and the third term is 3. Okay, here you can say that the common difference, small d, will be a2 minus a1, which is 2 minus 1 is 1. Okay, now suppose let S100 be the sum of first 100 terms of a natural number. Okay, so this will give, we know that the sum of the first n term of an AP is given by the formula Sn is equals to n by 2 2a plus n minus 1 d. Okay, here S100 will be equals to value of n is 100 divided by 2, the value of the first term is 1, and n again is 100 minus 1, and the value of common difference d is 1. So putting the value and solving it, we will get, this will be 52 plus 99 into 1, which is 52 plus 99, which is 50 into 101, and this is what, 5050. Okay, so 5050 is the sum of the first 100 term of a natural number. So in the sequence of natural number, if we add 1 plus 2 plus 3 plus 4 plus dash 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 till up to 100, we will get the value of the total sum is 5050. Okay, so in this way we can solve the sum of the first nth term formula. Let us solve more question to understand it better. Dear students, one question is written on the whiteboard. Just look at it. Question says that find the sum of the first 20 term of an AP in which the common difference is 5 and the nth 20th term is 135. Okay, we have to find the sum of the first 20 term when the common difference which is 5 and 20th term is 135. Okay, so I request all the students to pause the video and try it by your own. Now see, here given that common difference is 5 and the 20th term which is written as a plus 20 minus 1 is equals to d is 135. Okay, this will give a plus 19d is 135. Okay, so a20 is 135. Okay, dear students, suppose this is equation number 1 and this is equation number 2. Okay, so put 1 in a 2. What I will get? I will get this 1, since the 20th term is 135, so I can simply write a plus 19 into d is equals to 135, and putting the value of 1 in 2, I will get a plus 19 into 5 which is equals to 135. Okay bachcho, here 19 into 5 is 95 is equals to 135. So this will give the value of a is equals to 135 minus 95, which is 40. Okay, which is 40. So the value of a, which is the first term, is 40. This give the value of first term a is equals to 40. Okay, now we all know that the formula for the sum of the first n term is given by, here sum of the n term is given by n by 2, 2a plus n minus 1 d. Okay, here the value of n is 20 because we aim to find the first 20 term, so we will take the value of n is equals to 20. This will give as 20, the sum of the first 20 term is equals to 20 divided by 2, 2 into the value of a is 40 and is again 20 minus 1 into d, d is 5. This will give 10 into 80 plus 19 into 5. Okay, and this will give 100, this will give 10 plus 80 plus 19 into 5 is 95. So this will give 80 plus 195 is how much? 175, and 10 into 175 is 1750. Okay, so the sum of the first 20th term is 1750. Okay, in this way, dear students, you can solve more questions. So now let us see some more question to practice. Dear students, before we proceed to next question, I just wanted to give you one formula that gives the relationship between the nth term of an AP to the sum of the first nth term of an AP. What it is, let us just see. So far we have learned the formula, dear students, that the nth term is given by a n minus 1 d, okay, and the sum of the first n term is given by Sn n by 2 2a n minus 1 d. Dear students, let me tell you, we can write the sum of the first n term in term of last term also. Suppose this can be rewritten as Sn n divided by 2 a plus a n minus 1 d, okay, and substituting this value over here, we will get Sn is equals to n by 2 a plus a n, okay. This is the one formula which gives the relationship. This is the one formula that gives the relationship. This is the one formula that gives the relationship between the nth term formula to the sum of the first nth term formula. Suppose the nth term is replaced with last term, so this formula can be rewritten as Sn is equals to n by 2 a plus l, okay. Here we have established the relationship between the sum of the first n term to the last term and the first term, okay, dear students. But here the most noteworthy point is that you know that the nth term an can be written as Sn minus 1, okay. This is the relationship between nth term to the sum of the nth term, that an, the nth term, can be written as Sn minus 1. So based on this formula and this formula, the examiner asks you the multiple question. So we should know these three formula, okay. So now let us just solve one question based on these three formula. Now dear students, we have one question based on the concept that I just have taught you. Question number 3 says that the sum of the first n term of an AP is 3n square plus 6n. Find the nth term of the AP. Okay, so dear students, I request you all to pause the video and start solving it by your own. Everyone, pause the video and start solving it. Okay. Now see dear students, the solution for the question is, we are given the sum of first n term, that is Sn is equals to 3n square plus 6n, okay. So if the sum of the first n term is this, so the sum of the first n minus 1 term will be, if we replace n to n minus 1, we will get the sum of the first n minus 1 term, which is 3n minus 1 whole square plus 6n minus 1, okay. Now dear students, I just now I have taught you that the relationship between the nth term and the first sum of the first nth term is Sn minus 1. Now substituting the value of Sn and Sn minus 1 on this formula, we will get the Sn is 3n square plus 6n minus Sn minus 1 is 3n minus 1 whole square plus 6n minus 1 open bracket close, okay. This will give us 3n square plus 6n minus, this will give 3n square plus 1 minus 2n. Dear students, here I have use one algebraic identity, which is a minus b whole square, which is a square plus b square minus 2ab. This is the algebraic identity I used to expand this. So I will get n square, 1 square is 1 minus 2n. Okay, and and this will give us 6n minus 6. Okay, open bracket close. This will give 3n square, 6n. This can be rewritten as 3 into n square. 3 into 1 is just 3. 3 into minus 2n is 6n plus 6n minus 6. Okay, this and this will get cancelled out. 3 minus 6 is minus 3. So we will write 3n square minus 3. And here we will get 3n square plus 6n. Open this bracket, we will get 3n square plus 6n minus 3n square minus minus plus, so it will be 3. This and this will get cancelled out. The remaining will be 6n plus 3. Okay, so the resultant answer is, dear students, the sum of, so the nth term formula is 6n plus 3. Okay, and this is the answer. I hope, dear students, you have understood the things. Dear students, one question might be visible to you in your screen. The ratio of the sum of the first m and first n terms of an AP is m square ratio n square, so that the ratio of its mth and nth term is 2m minus 1 ratio 2n minus 1. Okay, everyone try by your own. Pause the video and try it by your own. Okay, so dear students, we are given sum of the m term upon sum of the n term equals to m square upon n square. Okay, so we know that the sum of the first m term is given by Sm upon Sn. The sum of the first m term is given by m by 2, 2a plus m minus 1 into d, divided by sum of the first n term is given by n by 2, 2a n minus 1 into d. Okay, and that is equals to, according to question, it's equals to m square upon n square. Okay, we need to show that the ratio of the mth term to the nth term is equals to 2m minus 1 upon 2n minus 1. So for this, now here let us do the cross multiplication. We will get m by 2, 2a plus m minus 1 into d. We will multiply this to here and this to here for the under the cross multiplication process. So we will get n square, which is equals to m square into n divided by 2, 2a n minus 1 into d. This will give, here dear students, you can observe that on LHS m is there, on RHS m square is there. So m will get cancelled out, so m square part is eliminated. Similar to this, on RHS we are having n, and on LHS we are having n square. So n square will get cancelled out, and also this divided by 2 and divided by 2 will also get cancelled out. Now what remain with us are the expression 2a m minus 1 into d whole bracket and here m into 2a n minus 1 d. Okay, now opening this bracket we will get 2a n plus m minus 1 into d into n, and here m into 2a, m into n minus 1 into d. Okay, so here as we can observe that when we transpose this term to here and this complete expression to RHS, we will get 2an minus 2am, which is equals to m n minus 1 into d minus n m minus 1 into d. Okay, this will give us, we can take 2a as a common, so it will be 2a n minus m, and here it will be m n m into m into n is mn, m into minus 1 is minus m, bracket d, here n into m, and minus of n into plus minus of n, so that will be plus ka n whole bracket d. Okay, and on opening this again, this bracket, we will get, here I can write mn d minus md minus nm into d minus nd minus nd. Okay, so here you can observe that this and this will get cancelled out. What remains over here is that minus d, n minus d, nm and d. Okay, what remain over here is that minus of m d minus nd. Okay, here we can take minus 1 as a common, so it will be m minus n d, and again taking minus 1 as a common, we can get n minus m into d, and here we are having this LHS part is 2a n minus m, so this implies, here also it is 2n minus m as it is. Okay, so this will give nm will get cancelled out, this give the value of 2a is equals to d, that means we are having common difference d is equals to twice of a. Okay, now after this the nth term, a nth upon the nth term, the ratio of nth term upon the nth term can be written as a plus m minus 1 into d, and here it can be written as a plus n minus 1 into d. Okay, this will give, since we are knowing that value of d is 2a, so I can write here as a plus m minus 1 2a divided by a plus n minus 1 into 2a. Here by taking a as a common, we will get a as a common, we will get 1 m minus 1 into 2, and this denominator will give us a 1 n minus 1 into 2. A will get cancelled out. What will remain here is 1 plus 2m minus 2 divided by 1 plus 2n minus 2. This will give 2m minus 2 plus 1 is minus 1, and here also minus 2 plus 1 is minus 1, so this will give 2n minus 1. Okay, so hence proved. Okay, so dear students, that was the end of the video. Thank you everyone for watching. Keep practicing more questions from the NCERT book. Happy learning!